Welcome to The Explainer. Today, we are taking a grand tour of one of the most amazing pieces of engineering in the universe. And the best part? You carry it with you everywhere you go. So let's explore the incredible blueprints of the human heart. But first, let me ask you a question. What do you think is the single most important, most reliable, most hard-working pump in the entire world?
Well, the answer is, of course, humming away inside your chest right now. It weighs less than a can of soup, about 300 grams, but it works relentlessly for you, every single second of every single day. We are, of course, talking about the human heart.
All right, so for the first part of our tour, let's figure out where this amazing engine room is actually located and what its basic layout looks like.
The heart's location is just genius. It's not just floating around in there, it's tucked away safely in a spot called the mediastinum, perfectly protected right between your lungs. Its pointy tip, the apex, rests on the diaphragm, and the wider top part, the base, lines up with your upper back vertebrae. It really is at the core of everything.
So what is this fortress actually made of? Well, the heart wall isn't just one simple muscle. Nope. It's this really sophisticated structure with three totally distinct, specialized layers. Okay, so on the very outside, you've got the epicardium. On the very inside, there's a super smooth lining called the endocardium, which makes sure blood flows without a hitch. But the real star of the show, the main event, is that middle layer, the myocardium. This is the functional hero. It's a special kind of muscle that's built to contract in perfect rhythm, and it's basically tireless. That's how it manages to beat over 100,000 times a day without ever needing a coffee break.
And as if that's not enough protection, this whole fortress is wrapped in another layer. It's inside this double-walled sac called the pericardium. And inside that sac is a tiny bit of fluid that acts like a lubricant. This lets the heart beat millions and millions of times without rubbing up against its neighbors and causing problems. Pretty smart, huh?
All right, so we've seen the outside walls. Now let's step inside the building and check out the main rooms, the four crucial chambers where all the magic happens.
Now, the absolute key to understanding the heart is to think of it as two separate pumps that are just fused together. The right side is in charge of what's called the pulmonary circuit. Its only job is to send that used oxygen-poor blood over to the lungs for a quick refill. The left side, though, that one handles the massive systemic circuit, pumping all that fresh oxygen-rich blood to literally every other part of your body. And each of these two pumps has two rooms. The top rooms are the atria. You can think of them as the receiving lobbies. The right atrium collects all the used blood from the body, and the left atrium collects all the fresh blood from the lungs. Now, the bottom rooms are the ventricles, and these are the powerhouses. The right ventricle pumps blood just next door to the lungs, while the left ventricle has that huge job of pumping it out to the whole body.
And just how massive is that job? Well, get this. The muscle wall of the left ventricle is about 3 times thicker than the right one.
So why? It's really just simple physics. The right ventricle only has to push blood a few inches to the lungs. That's a short trip. But the left ventricle, it needs to generate enough power to push blood all the way down to your toes and all the way up to your brain. So its design, its form, perfectly follows its function.
Okay, so with all this blood getting pumped around, you absolutely need a perfect traffic control system. You can't have blood flowing backwards. That would be chaos. And that's where the heart's valves come in. Just think of them as these brilliant one-way doors that make sure traffic only flows in one direction.
And there are 4 of these gates. You've got the atrioventricular, or AV valves, which are the doors between the top and bottom chambers. That's the tricuspid on the right and the mitral on the left. Then you have the semilunar, or SL valves, which are like the main exit doors leading out of the heart, the pulmonary on the right and the super strong aortic valve on the left.
And here's something really cool that you might not know. That classic lubbed-up sound of a heartbeat, that's not actually the sound of your heart muscle squeezing. It is literally the sound of those valve gates snapping shut. The lub is the AV valves closing, and the dup is the SL valves closing a split second later. It's the sound of perfect timing.
Okay, so we've seen the location, the walls, the rooms, and the doors. Now it's time for the grand finale of our tour. Let's put it all together and follow the complete, amazing journey of blood as it goes through this great circuit.
Let's trace it step by step. Okay, so used deoxygenated blood from the body comes into the right atrium. Whoosh! It passes through the tricuspid valve into the right ventricle. Then, bam! The right ventricle pumps it through the pulmonary valve to the lungs to grab a fresh tank of oxygen.
That new, bright red blood zips back to the left atrium, flows through the mitral valve into the powerhouse left ventricle, which then gives it a mighty shove through the aortic valve into the aorta, the body's superhighway, to be delivered everywhere else.
And here's the kicker. That entire, elegant six-step journey happens completely with every single beat of your heart. In about 1 second. Over and over and over again. Just incredible.
Now, before we finish up, I have to share one last fascinating little detail in the heart's design. Think about the aorta, right? That giant artery carrying all the fresh blood out to the body. What do you think is the very first branch off that artery? The very first delivery it makes? It's the coronary arteries.
So what does that actually mean? It means the heart pays itself first. Before it sends a drop of that fresh oxygenated blood to your brain or your muscles or anywhere else, it takes the very first richest supply for itself. It's the ultimate example of secure your own oxygen mask before helping others. The heart instinctively knows it has to stay strong to keep the whole operation running.
Which really brings us to our final thought. We've just toured a complete marvel of natural engineering, a pump that is designed from the ground up to sustain us from our very first moment to our last. So the question it leaves us with is this: if the heart is so perfectly designed to sustain us, how can we best sustain it?